In this video, I will talk about the types of actions that ML agents can perform. You will learn which tasks are best suited for each type of action, which trainers they work best with, and how to inform the agent that a certain action is prohibited. The Unity ML Agents framework supports two types of actions, discrete and continuous. The difference between these types of actions can be easily understood by looking at a gamepad. Gamepads have buttons and sticks. Sticks are continuous control elements, allowing smooth control of the agent. For example, a continuous action can slightly steer a car's wheel. Buttons are discrete control elements and have a defined state, pressed or released. You can control a car using buttons too, but the accuracy significantly suffers. However, discrete actions are not as simple as they seem. In more complex cases, a discrete action can have more than two states. For example, if our agent needs to choose which piece to move in chess, this can only be implemented using a discrete action with 64 states, one for each available square. In ML agents, actions are defined in the behavior parameters component. For continuous actions, you only need to specify their number. For discrete actions, you need to specify their number and the number of states. As a small demonstration, let's take the code from the previous lesson and modify it slightly. Part of the environments will be controlled by continuous actions, and the other part by discrete actions. The agent will be controlled by two actions. One action tells the agent to move forward or backward at a certain speed, and the other action tells it which direction to turn. From a coding perspective, an analog action returns a value from -1 to 1, while a discrete action returns an integer from 0 to the number of declared states. In our case, there are 3 states for each action: stand still, move forward, move backward for the first, and turn left, not turn right for the second action. Let's take a look at the implementation of the onActionsReceived method for the discrete agent. We expect values from 0 to 2. Read them from taken by agent actions. Then we convert taken values to convenient and apply them to the agent's state. Subtracting 1 from the value accepted by the agent gives us convenient values for controlling the agent. Let's start the training. As we can see in our example, the agent controlled by discrete actions learns faster. This is because it always moves and turns at the maximum available speed, whereas the agent under analog control acts more cautiously. Thus, we can conclude that the same task can be solved in 2 ways, and sometimes, to confirm a hypothesis, a less precise but faster method can be used. Regarding training strategies, we haven't touched on this topic yet, but in general, there are 2 types of trainers: PPO, Proximal Policy Optimization, SAC, Soft Actor Critic. Briefly, PPO is suitable for simpler tasks. It works well with both types of actions. SAC is designed to solve more complex tasks based on a lower amount of data, where some time may pass between actions and rewards, and works better with continuous actions. Finally, it is worth mentioning that when using discrete actions, there is sometimes a need to prohibit certain actions, for example, due to game rules. A rook moves only in a straight line and cannot jump over pieces. There are several ways to solve this problem, but Unity ML Agents also allows you to directly mark actions as prohibited. Simply specify the branch and the index of the action in the branch. I hope this lesson was useful to you. Support my channel by subscribing and liking the video. If you have any questions, write in the comments or on the Discord server mentioned in the video description.